Assalamualaikum warahmatullahi wabarakatuh, and hello everyone. We are from Group A are going to present about the drainage systems. These are our group members: Muhammad Taufik bin Amir, Kabilan Govindasamy, Dewi Mustika binti Masri, Intan Afika binti Hussein, and Nur Sabiha Hafiza binti Muhammad Shani. My name is Intan Afika binti Hussein. I will talk about the introduction. Drainage systems are required in any region to protect and promote public health and welfare, to prevent against flooding, to minimize water pollution, and to improve economic development. Drainage is the process of draining water from the surface or subsurface of a specific area, all of the pipe on a private or public property that transports sewage, rainwater, and other liquid waste to a place of disposal is referred to as a drainage system. The hydrologic cycle is impacted by urbanization in various ways, including decreased infiltration and concentration times, as well as increased flood peak and runoff. Furthermore, population increase, changing precipitation patterns, deterioration of sewer infrastructure, as well as blockage and sedimentation, all contribute to drainage system failures. That is why drainage is an important part of any community's infrastructure, and its restoration costs local governments a lot of money. In this project, we shall determine and identify the type of drain applicable for CH0 meter to CH600 meter along the proposed route, analyze and sketch the direction of flow within the drain along the 600 long proposed route, and design the size for a chosen drain system. Consider the rational method for a 20 years annual rainfall intensity event and the rainfall station at Kampung Sungai Yap, which is located at Jerantut, Pahang.
Greetings, Doctor. I'm Kabilan Govindasamy from Section 5. Today I will be presenting the objectives and the problem statements for our project. The objectives are to determine the type of drain which are suitable along the proposed road for CH0 meter to CH600 meter. To analyze the direction of flow within the drain along the proposed 600 meter long road, and to design the most suitable and economic size for a chosen drain system along the proposed 600 meter long road. For the problem statements, our group have chosen Kampung Sungai Yap for our final project, along with that project site just having the cut earthwork and the fill earthwork in order to construct a 600 meter long road. The landslides areas should be stabilized to prevent the slope failures from occurring, and the slope failures are mainly caused by the groundwater. A safe road to be used, as it can prevent landslides areas together with also reducing the slope failures. The landslide areas should be stabilized also by removing additional drainage when the slope failures happen. The road damage along with the problems about the serviceability of the road networks are caused by excess water fills in the pores of the road materials in the roads and in the subgrade soils. The well-designed drainage should prevent the early pavement distresses as well as the structural failures of the road and the slope failures to be occurred. Thank you.
Assalamualaikum. My name is Muhammad Taufik bin Amir. My matric number is CF21103. Now I want to tell about methodology. The process to design the drainage. The first is select design ARI, discrete subcatchment, estimate time of concentration, determine average rainfall intensity, calculate runoff coefficients, calculate peak flow rate, and design the drainage. to determine and to label the type of drain suitable along the proposed route for CH 0.0m to CH 600.0m. We need to calculate the difference in slope height of the hill. Hence, we are able to determine the cut earthwork along with the fill earthwork. Moreover, our group also know to use which type of drain along the proposed route for CH 0.0m to CH 600.0m. The berm with drain is constructed if the certain hill is undergone the earthwork. When the difference in slope height of the hill show negative value, the earthwork is cut, whereas the earthwork is filled when the difference in slope height of the hill shows positive value. Based on the JKR standard drawing for roads, the type of a drain used is the roadside drain, the bench drain together with the interceptor drain when the earthwork is cut, whereas the type of drain used is the shoulder drain, the berm drain, and the embankment toe drain when the earthwork is filled. Last but not least, the difference in slope height of the hill determines the number of drain must be applied on the particular part of the channel. This is the difference in slope height of the hill. If less than 6 meter, the cut earthwork is roadside drain. For the fill earthwork is shoulder drain. For more than 6 meter but less than 12 meter, the cut earthwork is roadside drain and bench drain. For fill earthwork is a shoulder drain and berm drain. For more than 12 meter, the cut earthwork is roadside drain, bench drain and interceptor drain. For fill earthwork is shoulder drain, berm drain and embankment toe drain. That's all. Thank you.
Hello and hi everyone, my name is BFC21103 and I will present about the result and calculation. First, every group should propose 10 continuous changes from 25 total of section. We choose the change from 375 to 600 to be evaluated in this study. We divide the area into 3 sub-catchment areas, which Area 1, Area 2 and Area 3. From the left side of the highway, type of drain included in this change is shoulder drain, roadside drain, bench drain and interceptor drain, which include fill and cut work. Next, for the right side of the highway, we will just need the shoulder drain, roadside drain and a bench drain. From change 375 through to 475, we will do the cutting work. From change 500 to 575, we will do the filling work, and at 600 change, we will do the cutting work again. Next is runoff coefficient C. We use the formula to obtain the value of C by using the information given. These are the runoff coefficient for each sub-catchment area, from first area to second area and the second, and lastly the third area. We have calculated the average rainfall intensity by using the formula. For each drain, we will also calculate the flow rate by using the formula of Q. So, we have been choose this change type. For the roadside drain, we choose roadside drain type 2. For the interceptor drain, we choose type 2 interceptor drain. Rinse drain type 1 and shoulder drain type 1.
My name Nur Sabia Hafiza binti Muhammad Shani, metric number CF200244. I represent discussion and conclusion. Discussion. The annual rainfall in city in 20 years is about 70 mm per hour if the storm duration is about 100 minutes. The duration used to calculate rainfall in city for the proposed channel is 33.2 hours. If the duration taken is lesser than 24 hours, the channel is flood across will increase if thrown whole day long because the channel cannot withstand the flow. The waterways are generally compound channels, consisting of a main channel and floodplains of varying geometry and roughness. Relationship describe the behavior of fluid flowing in open channels are derived by using the Reynolds-Transcott theorem as point of departure. Subsequent, the derivation of conservation of mass, linear momentum, and energy equation the concept of specific energy to determine the true strength F inner capacity to direct the flow Q. Q equal to 1/n 8R 2/3 slope 1/2. All the design and chosen drains have greater flow capacity than the flow that might channel through it. After calculate the flow for the drain and also the channel section 38, the design drain proven to be suitable along the proposed road. Conclusion. In this project, we were assigned to design side of the chosen drain system. We were able to apply hydraulic knowledge to do the calculation to use in designing. We also including the flow of additional channel areas such as interceptor drain, branch drain, and roadside drain. The project used some of the basic methodologies developed for composite compound channels either due to lack of input data, lack of time, or lack of funds. Since the velocity will remain constant in very cross-section at uniform flows, energy line slope, hydraulic grip line slope, water surface slope, and channel bottom slope are equal to each other and will be parallel as well. Plus, all of the flow rate design is greater than maximum flow rate for each channel, interceptor drain, branch drain, and roadside drain. That's all from me and my group members. Thank you.